Hello and welcome to Future Review. Today I'll be sharing with you part 2 of the Challenges of Galactic Empire series. In this part and every other part moving forward, I will assume that the problem discussed in part 1 of the series, the faster than light problem, has been solved. This, for reasons that I explained in part 1, is because without safe and reliable faster than light travel and communication, the titular Galactic Empire, a unified human galactic civilization, is effectively impossible. And so I'll be assuming that this is, in fact, the case, that we have faster than light travel and communication, because without it, the rest of the series could not really occur. And with that, let's get into this video. Many of the problems that we initially face if we seek to become a galactic empire are logistical, simple matters of how do we do this physically. That was the case in part 1. How do we physically reach the stars, because they're actually quite far away? And as we saw, that on its own is very difficult. It may or may not require the breaking of a few laws of physics. But assuming that we can do that, assuming that we can actually reach other solar systems and colonize other worlds, well, that leads into an immediate other problem. That being, where do we settle? What other planets do we settle on? What planets can even support human life? And that's the topic of this video, what I'm going to call the inhospitable planets problem. The fact that most planets are not at all suitable for human life. Their conditions are just too extreme to easily support human life. To settle on them would require vast engineering interventions. There are a myriad of factors for why most planets in the universe are likely completely unsuitable for human life. Wrong temperature, high levels of radiation, no or poisonous atmosphere, extreme gravity, being a gas giant with no actual surface to land on. They're just a few of the factors that can make settling other worlds effectively impossible. Even within our own solar system, there are many examples of planets that would be not very easy to settle on. Take Mercury, for instance, the first terrestrial planet in our solar system. Mercury is not suitable for human life in any real capacity. Mercury is too close into the sun for human habitation. In conjunction with the fact that Mercury is tidally locked, meaning that one side eternally faces the sun while it orbits, while another never sees its light, means that one side of Mercury, the lit side, is about 800 degrees Fahrenheit in temperature, whereas the dark side is about negative 280 degrees Fahrenheit in temperature, neither of which is very good for human life and require significant engineering investment to settle anywhere on the planet. Additionally, Mercury has basically no atmosphere, which means we can't breathe on it because we need to breathe, and so we'd have to constantly be in our spacesuits or within the colony to even exist on that world. And another thing about Mercury that's a problem is that because it is so close to the sun, the lit side is constantly blasted by high levels of solar radiation, which we can't handle, obviously. And so for all these reasons, Mercury is a pretty bad real estate for human settlement. And so it would really not be our first choice. It has terrible conditions for human life. And that characterization also extends to Venus, the second planet from the sun, and much closer to Earth. In fact, Venus also not only is it closer to Earth, it's actually almost the same size as Earth and same mass as Earth. This is why Venus is often called the twin planet of Earth. Unfortunately, that's about where the welcoming characteristics end, because despite being named after the Roman goddess of love, Venus is actually a hellscape. And the main problem with Venus, or at least the most obvious one for human settlement, is the atmosphere. You see, Venus's atmosphere is kind of in the reverse situation as Mercury's. Mercury had too little atmosphere for human comfort, whereas Venus has too much. Venus's atmospheric pressure is over 90 times that of Earth. To stand on the surface of Venus is to experience an atmospheric pressure equivalent to being a kilometer underwater, yet not suitable for human life. Additionally, Venus's atmosphere is over 95% carbon dioxide, which means that most solar heat that reaches Venus is trapped on the planet. It doesn't radiate out into space like it does on Earth, which means that Venus has experienced a runaway greenhouse gas effect, which which leads the entire planet to be over 100 degrees Fahrenheit. It's even hotter than Mercury despite being significantly further away from the sun. And unlike Mercury, there's no way to hide. There's no other side of the planet to escape the heat. It really says something that on Venus, the exploratory rovers that we've sent there, specifically designed to withstand the pressure and the heat, still only last a few hours, just enough time to take some pictures and some survey data. You can imagine how humans will fare in those conditions. There are actually other reasons why Venus is completely unsuitable for human habitation, but the atmosphere alone just rules it out entirely, so I think I'll leave my description of Venus at that. And let's also talk about Mars a little bit. Everyone's favorite for colonization, and with good reason, actually, for reasons I'll explain now. Mars has its challenges to colonize, but it's a lot better than Mercury or Venus. Mars has a similar problem to Mercury in its atmosphere. Mars has a very thin atmosphere, which doesn't shield it from radiation at all. So while Mars receives less intense radiation due to being further away from the sun than Mercury, it still receives a significant amount of radiation that would be a problem for humans. And unlike Mercury, Mars is entirely locked, so there's no side of the planet where you can hide out from the radiation. So that would be something you have to contend with. But after that, it gets better because in terms of temperature, Mars is actually okay. It can actually be dealt with just by regular humans right now. The average temperature on Mars is about negative 80 degrees Fahrenheit, which is a lot better than the negative 280 degrees Fahrenheit on Mercury and the over 800 degrees on Venus. Another thing to factor in, though, is that that's the average temperature on Mars. As it turns out, Mars has seasons, actually, which means that temperature variation throughout the year and on different parts of the planet can be quite significant. On some parts of the planet, at certain points of the year, Martian temperatures can be up to 95 degrees Fahrenheit. That's right, positive 95 degrees Fahrenheit. So the Martian climate can range from Caribbean to Siberian, both of which can actually be dealt with by humans. And another thing to consider is that if we settle at either the poles or the equator, the seasonal variations won't be so much. So maybe that's our best bet. But in either case, that's not actually so bad to deal with. But another thing on Mars that we have to deal with that is unique as compared to Venus or Mercury is the natural disasters. Mars has quakes from tectonic activity as well as volcanic eruptions from volcanoes, some of which are actually larger than any that exist on Earth. So that's something we have to keep in mind. Another uniquely Martian natural disaster we have to keep in mind is, of course, the dust storms, because Mars is a very dusty planet, and the dust storms there can last for months and cover significant portions of the entire planet. Dust, of course, can interfere with delicate electronics and or life support, and so that's something that we have to plan for. But all in all, Mars is actually a pretty good bet by comparison. It's no wonder that it's everyone's favorite to colonize, and it would make a pretty good start to the human's journey into space, being relatively close to Earth within the same star system, and not too bad to colonize, not too many obstacles by comparison. But the problem is that after that, the options get limited. Exoplanets can be even more extreme than what we've just discussed. Take, for instance, HD 189733b, about 65 light years away from Earth. HD 189733b is a planet where it rains molten glass sideways due to the wind speeds being up to 5,600 miles per hour. Now, I am being somewhat misleading on that one because HD 189733b is a hot Jupiter, meaning a gas giant close to its star, hence the name hot Jupiter. Of course, you can't land on a gas giant anyway, there's no solid surface, but I use that to illustrate just how extreme exoplanet conditions can actually get. As for actual rocky planets that you could conceivably land on, take for instance Kepler 78b, 560 light years from Earth. Kepler 78b is about the same size as Earth and even about the same mass, which looks pretty good, right? Well, wrong. No. Kepler 78b is 40 times closer to its star than Mercury is to our own, which leads to some interesting things. A year on Kepler 78b, meaning one complete orbital revolution, takes several Earth hours, The surface temperature is about 2400 degrees Fahrenheit, and the entire planet is covered in lava. Astronomers are actually quite baffled. They don't have a clue as to how a planet like that managed to form so close to its star. The planet is actually being torn apart by the star's gravity due to being so close, and will actually be completely consumed by its star in about 3 million years. So no, not particularly conducive to human colonization. Or take, for instance, the planet 55 Cancri E, about 41 light years from Earth, fairly close actually. But there's your problem. That's about where the good things end, because 55 Cancri E has a similar profile to Kepler 78b, thousands of degrees Fahrenheit, covered in lava. Although, interestingly enough, that planet might be mostly made of diamond, so maybe it has a use other than for colonization. Diamond is a very useful industrial material, after all. It could be useful for a galactic civilization. And I just use those exoplanets to illustrate just how weird um, planetary conditions outside the solar system can be. But the thing is that they're in some ways the rule rather than the exception. Most planets outside, like as far as we can tell, basically every planet outside of our solar system is not at all welcoming to human life. It may well be better to just live in orbital platforms above the planet than actually live on planets. But that's a discussion for a separate time. And after this, I would actually like to talk about potential means to mitigate the risks detailed above, because it's not all doom and gloom on this channel. For instance, with radiation, there are actually a few countermeasures you could take to mitigate or perhaps eliminate the risk altogether. Um, you see, with radiation, there are two potential solutions to that. One is building underground, depending on the composition of the planet itself, because if you build underground deep enough, radiation might not penetrate that far, and so you can just eliminate the risk altogether. And if you were to build on the surface, you could theoretically just line the colony with lead. And that makes sense because if you're colonizing in space, resources probably aren't a problem. And if you could line it with your colony with enough dense material, you might actually be able to just block the radiation, so it wouldn't be a problem. Additionally, if you're on a tidally locked world, which a not insignificant amount of exoplanets are, you could just settle on the cold side of the planet, because the cold side of the planet is the side of the planet that never actually faces its star, which means you wouldn't receive any radiation anyway. So that's another way to potentially eliminate the risk altogether. In general, radiation is one of the easier risks to mitigate, so that one's not so bad to deal with, even though it sounds bad because radiation's scary. And temperature is kind of in the same boat. There are a variety of ways to potentially mitigate that. If a world is very hot, you could potentially install heat shield technology on the outside of the colony, and such materials do exist. For instance, on the space shuttle, on the bottom of the space shuttle, there's special heat shielding that withstands several thousands of degrees as the space shuttle re-enters Earth's atmosphere, and so it could be possible to shield a colony from even such temperatures as on planets that were mentioned earlier. And on the other side, if a planet is very cold, and there are very cold planets out there, I didn't mention any, but they do exist. On a cold planet, you could potentially install insulating material on the inside of the colony and use waste heat from the energy generators in the colony that you would presumably have for all the advanced equipment that you would need. And that could possibly keep your colony nice and toasty. In any case, and also, if a world is tidally locked, this could also help with temperature, not just radiation, because you could settle in the twilight zone of the tidally locked planet, the space on a tidally locked planet where the light side and the dark side of the planet meet, where the temperature would be a lot more moderate. It may still be quite extreme, but not nearly as extreme as the rest of the planet. And the radiation there would also not be too bad. So if you're going to be on a tidally locked planet, the twilight zone is looking like your best bet for two reasons. And for radiation and temperature reasons. The problem is that it's not so easy for something like atmosphere, because in either the case of no atmosphere, or a very thin one, or just a poisonous atmosphere, an unbreathable one, the solutions are pretty much the same. You're just gonna have to wear a spacesuit or stay within the colony or wherever the oxygen generators reach, because in either case, there's really no solution other than extensive terraforming. You'd have to either bring your own atmosphere if one doesn't exist already, or you'd have to convert the existing unbreathable atmosphere into something more oxygen rich and something lacking in toxins, something that's not good for human breathing. So there really isn't much you can do about the atmosphere without extensively modifying the planet itself. But if you can do that, then obviously this isn't such an issue, but it is for us right now. We can't do that. And another thing that we can't control is gravity, because the gravity of a planet entirely depends on its mass, and we can't really do anything to change that, at least not yet. That would require some serious mega engineering to actually alter a planet's mass in any way that is noticeable. So we'd have to just deal with it. But if we had to settle on a planet that has significantly different gravity to Earth, one thing to consider is that lower gravity is better than higher gravity for two reasons. The first reason lower gravity would be preferable to higher gravity on a world that we would colonize is the effects on the human body. Lower gravity than Earth has serious effects on the human body. It causes atrophy, as we see in astronauts. However, astronauts also give us the potential solution, which is exercise. If you exercise your body, you can keep your muscle and you can keep your strength, which will allow you to return to Earth. Of course, on some worlds that may require a lot of exercise, but maybe we shouldn't pick worlds with too low gravity. At least it can be mitigated to some degree. This cannot be said of high gravity worlds. High gravity also has serious effects on the human body, as can be seen with pilots being exposed to high G forces, even momentarily. The problem is that there's really no way to mitigate high gravity on another world. The human body would just be stuck under that strain forever. And like I said, as we've seen with pilots, even small amounts of time under high G-force can cause serious health problems for the human body. On worlds with high enough gravity, long-term human settlement would probably not really be possible because of the bad effects on the human body. And so, because of the fact that you can at least mitigate the problems of low gravity on the human body, and you pretty much can't on high gravity, low gravity is preferable for the sake of human health. And the second reason that lower gravity would be preferable to higher gravity if you had to choose a world that had significantly different gravities to Earth is building, ease of development for the colony, because of weight. You see, materials have the same mass no matter where they are in the universe, but they don't have the same weight, because weight is mass times gravity. And so on a world that has, say, low gravity, building would actually be easier than it is on Earth because materials weigh less. You can build taller and more compact buildings, or not more compact, but more spaced out buildings, both wider buildings and notably taller buildings, because you can with less materials and less durable materials too, because the building would weigh less and wouldn't be so liable to collapse in on itself. The exact opposite is true in a high gravity world. You would need stronger materials, and you would also have to build shorter and more compact buildings, which might waste precious space depending on the world in question. And so on a lower gravity world, development would actually be easier because it's just easier to build on a world where things weigh less. Whereas on a higher gravity world, you'd have to be more careful with building, and you'd probably have to use more space on the ground, which is it's always easier to go up than it is to go wide, as we've seen in cities on Earth. And so for that reason, lower gravity would be preferable to higher gravity as well. And so we should generally look for lower gravity worlds, which is unfortunate because a lot of the more Earth-like planets we found are actually higher gravity, but maybe we can deal with that to some degree. And those are just some of the problems that we'd have to confront when choosing which planets to colonize in the future. I think we can solve them eventually, but it's going to be a challenge, especially at first. And that just about concludes the video. If you like that, remember to like, comment, and subscribe. And until the next video, goodbye for now.